So in the last video, we talked about using a force or applying a force to an object in the form of work and then transferring energy to that object. So in this video, I'm going to talk specifically about a few different types of energy. So let's say that I were to climb up to the top of a cliff and I were to hold a package above the ground. I have applied some force to that object to lift it up above the surface of the earth some height, right? So as a result, I have stored some potential energy in the package, and so the potential energy is stored. It actually wants to fall down towards the ground. Now the very generic variable that we use for potential energy is U. But we also do have some specific types of stored potential energy, and so sometimes we use a little bit of a variable. So this a different variable. So this is generic, but in this case, we're talking about stored energy that's a result of lifting something up above the ground. So we call this gravitational potential energy. And I usually write it with a GPE. Right? And the amount of work that we've done, remember that work is force times distance. So the force that we've wanted to overcome is gravity, which we know is Fg or mg. And d would be the distance or the displacement. And so that would be the height above the ground that the object has been lifted. So the actual equation for gravitational potential energy that any object has as a result of being above some relatively lower position is mgh. And so typically if we were to, say, release the package down off of the ground, as h decreases, so will gravitational potential energy, right? And it has a linear relationship. We could also solve for the change in gravitational potential energy, and most often that is a result of the height changing. It's not going to be because obviously gravity is not going to change, and the mass of the object most often does not change. It's possible that it does, but that is less common. So we could figure out how much gravitational potential energy is lost or gained by changing the relative position. Now, in this case, I have the ground as being position 0, but if we're dealing with, say, a roller coaster problem, where we have a roller coaster like this, and here's the ground, but here's the relatively lowest position in the system, we could use this as our height and set this as position 0, right? So again, this is energy, so our unit is going to be joules. So that's one type of stored potential energy. Now, another type of potential energy is the potential energy that happens with things that are elastic. And for our purposes, we're going to use springs because they really are the most straightforward example. So if I were to take a spring and I have it at its resting position, right? So this is its rest position. If I were to then pull on that spring with some force in this direction, it will cause the spring to lengthen. Right? Now, I also could push it this direction and make it smaller, and the same thing would happen. So I have applied a force and have moved it some distance, right? So that's what work is. So I've added energy and I've stored energy into the spring, and if I were to release it, then that energy would change to a different form, which we'll talk about in subsequent videos, right? So this is some x. It's actually the change in position of the spring from its normal sort of rest state. So it would be from here to here. So this is EPE, or elastic potential energy. Let me move this up a little bit. And again, sometimes just generically we use the letter U. And this is actually equal to 1/2 kx squared, right? So the k is actually a constant that has to do with a property of the spring. Okay, so K is the spring constant, and it's really related to how many newtons are required to move the spring by a certain distance. So we know that, if you have a spring that's a real stiff spring, that if we were to try and pull it, it would require more energy than if you have something loose like a slinky. It would require less energy. So something about the property of the spring gives us the amount of energy that can be stored in that spring. So K is the spring constant, and the unit for K is newtons per meter. So that's the force that it takes to lengthen it by 1 meter. And that will be provided to you, or you have to calculate it somehow given the information, right? So that's how we calculate elastic potential energy. Now, the last kind of energy that I'm going to talk about in this video is the energy as a result of something having motion, right? And that is called kinetic energy. So if you have taken chemistry from me or from any chemistry teacher, really, we talked about kinetic molecular theory and how the motion of objects relates to temperature, and we'll go into detail more about that in physics too, if you're taking that. Right? So kinetic energy, which we write as KE, is equal to, and it's relative to the motion of the object. So 1/2, the mass of the object is going to play a role, and then V squared would be and this is the velocity. All right. So again, units are in joules. These are all energy units. So all we're really going to be doing to start with is solving for the amount of kinetic energy, gravitational potential energy, or elastic potential energy something has instantaneously, or changing some height, changing some x, or changing some velocity. Right? Also, we could look at how the change in mass is going to affect the magnitude of the kinetic energy. Right? In the last section of this unit, we'll actually go into how to calculate when energy transfers from one form of another and the conservation of energy.